Okay, hello and welcome everybody to our sixth webinar today with our guests Christian Mader from Fraunhofer IAIS and Jaroslav Pullmann from Fraunhofer FIT. Both are researchers and developers and are at the core team who deals with the information model of the IDS ecosystem. And this is also what they will introduce to us today. They will tell us some things about the information model as it is, what it is for, how it is constructed, and so on and so forth. Yeah, we will have some further webinars upcoming this year. At least 3 webinars will come up about the IDS connector, which will be on the 30th of November. Then we have another webinar about trust in the IDS at the 14th of December. And as some kind of Christmas gift for you, we'll have a last webinar for the last webinar for this year about the IDS information model policy language on 21st of December, again with Jaroslav. Yeah, but let's start with this webinar. Please, if you have questions during the webinar, just write them in the chat function of the GoToMeeting if you're watching this live, or you can ask the questions after the presentation in the Q&A session. If you're watching this on YouTube, you can simply write your questions in the comment section down below, or contact us via email, as you prefer. In the case you're watching this on YouTube, don't forget to follow our channel to not miss any further webinars. And of course, you can hit the like button if you like what you saw. Okay, then I would say let's start. Jaroslav and Christian, stage is yours. I'm very excited about hearing more about the information model. Hello and welcome.
Christoph, thank you very much for introducing us. My name is Jaroslav Pullmann. I'm an employee at Fraunhofer FIT, and one of my responsibilities is the development of the information model of the industrial data space. So I will give a short presentation about the current status around the model, around the community which has been built around the model. Okay, so just passing the tube to Christian.
Hello, my name is Christian Mader. I'm working at Fraunhofer IAS together with Jaroslav. We're co-located here in Berlin-Hofen, just to St. Augustine. And we're very closely working together on the information model. Jaroslav is mainly leading the conceptual part, and more of my responsibilities are to bring the information model to the users and to develop application on top of them. But we will shortly see how this is going to be.
Thank you. So next. So the agenda. We will look at the general overview of the model, what representations are. So these are different facets of the model, different views, or even representations, how they're used. So then we will deal with the model in more detail, following particular modeling concerns, which will be introduced. Information model in use is just a sample, a short sample. There are much more samples being built, especially in these times where integration has started. So yesterday we returned from an integration meeting in Dortmund, and the information model was at a epicenter of the integration activities. Ontology governance process will look at how the sources, for example, are maintained, what the processes has been set up, and how you could contribute to development of the model. And the summary will look at the more conceptual characteristics which are called concerns, and which are in flow of the presentation looked at and then summarized then at the end. And of course, there's a room for your questions at the end. So let's start with the overview. And then you would ask maybe what the information model really is, and I would respond, it depends, because there are different audiences. So the green circle just looks at the audience, which in this case is the general public. So if you ask by your neighbor or a manager at a booth in a presentation, or project partners with no background on IDS, then this is the reference you would give. This is the conceptual representation of the model, which is mostly a document where there are nicely looking and informative pictures, URML diagrams, and the embodiment of the conceptual representation is a document called the IDS reference architecture. And this is quite high level, and there are associated specifications for the individual components. So if talking about the information and the domain of the industrial data space at such a conceptual level, then it is the model, the information model you should look at. This is an example how it looks like. So there's a text with some details on how particular formulation of a model would look like, and with formalized depiction in UML diagrams. The next stage or the next representation of the information model is a declarative one, which is an ontology. It is used, the stakeholder group highlighted knowledge engineers, ontology engineers, which are interested in defining the formal background, the formal base of the industrial data space, regardless at the beginning, if looking at the core of the domain, but considering all the aspects which are involved in handling data, in sharing data, in expressing constraints on the use of such data. So all these are defined in terms of RDFO and so on. So these are ontologies of the semantic web holding data I will then refer to later. But if interested in a formal description of the overall domain of the IDS, the world of industrial data space, you would look at the declarative representation, which is embodied in an ontology. All the sources where you should look for the individual representations are pasted below. So then if you are given the slides, just follow them, follow the links, and then look, please, at the different embodiments of the model. There's no hard link between the conceptual and the declarative one. The conceptual just sets out the framing, informs the definition of the ontology. How it looks like, so this is the background on, I will not deal with this in detail. The ontology is, of course, defined in terms of W3 standards of the semantic web and linked data activities, which especially is the resource description framework, which is quite a simple model consisting of a generic model called triple. It consists of a subject which is made an assertion or a statement about using a predicate, and the object is the value, like a person, his name, Christian. And myriads of such linked statements, especially if you are identifying the resources, the subjects or objects by URIs, universal resource identifiers, then you are building up huge graphs which might be then exploded in searches and reasoning by additions of statements or assertions from the web ontology language. Shapes constrained language shackle is used, and other standards like RDF unit in order to maintain a consistent and high qualitative model. And the further standard, the WPC standard, Sparkle, is a query language used for even querying and inferencing and providing the benefit to end users using the information model or the ontology. So this is an example how the ontology, how the declarative representation of the information model looks like, with some statements which might look known to you, common to you, but there are some, for example, validation statements which were introduced by us, which is sort of meta model we leverage in our framework. Summarizing, the ontology model consists of schema and classes definition, which is referred to as a model, and as well quite extensive definitions of shared terms, which is vocabulary. All the model has been, of course, not been defined in context-free space, but we rely on standards like DCAT, provisioning ontology, ODRL for definition of the conditions of use, and so on. The very purpose of the ontology is to provide a vendor and software independent expression of the overall concepts, entities, and relationships in the information in the domain of the industrial data space, which is vendor and software independent, which is then further generic and reusable. And this is what the future developments will target. These are the extensions looking at the domains of healthcare, agriculture, energy, logistics. Then these base terms are going to be extended by vocabularies and ontologies. Of course, and if you have such an asset on sources, then you need to define a governance process. But we looked, for example, at a change in release management policy for DCAT. I will refer to it later on. So we were looking at the conceptual and the declarative representation. I will pass to Christian, which mostly looks at the programmatic representations, targeting or addressing the developer community.
Yeah, so as Jaroslav just told you, the declarative representation is mainly setting the stage for the data model and to describe everything in a standardized way. The problem here is that even though these are, as Jaroslav mentioned, standard technologies based on W3C standards, RDF, Sparkle, Shackle, and so on vocabularies are not really household names in the development community. So we found that there is a need to bring the information model closer to the development. So when you want to start using the information model, you first need a way to instantiate it. So you could do this, of course, based on the ontology that we provide in the declarative representation. But still, as I said, you need knowledge about these standards, about RDF. And in order not to have this knowledge and to address a wider range of developers and companies, we created a programmatic representation. So what this basically means is that we provide a library in a standardized language. So we started with Java. Probably there will be other languages be supported soon, but the basic idea stays the same. So what we'll do is that based on the declarative representation, we automatically infer libraries, as I said, Java in the first place, which can then be used for free by the development community to instantiate their models and use it in the connectors that they provide. So here is a screenshot of how this looks like. As I said, from each of the classes of the ontology, we are automatically inferring or creating interfaces in Java, which then can be very easily instantiated and used by connector implementations or broker implementations or whatever. So this is more or less a service now for the development community, but we see it also as a very, very central part of our efforts in bringing this information model closer to the actual users. We will see in the next slides for each of the theoretical underpinnings, or for many of them, also concrete examples about how this declarative representation of the information model is used in a practical way with this Java library. But be not mistaken, we don't force developers on using Java. We have first implemented this Java library as a support for the community, but of course everyone is allowed to create his own mapping and also contribute to this programmatic representation, so that in future, hopefully, we will be able to support a wider range of programming languages.
Thank you very much, Christian. So next slide just shows what the normative representation of these is, and if then looking for the through, what a single through and what a single point of reference is, then this is the ontology. And as Christian said, by means of model transformation, we arrive at different, even deferred or inferred programmatic representations. But it was the experience we had with developers, which was an eye-opening experience. They just didn't know about ontologies and didn't really care about ontologies. And in order to onboard and to bring in, introduce them into the project, they were requesting for just a POJO, plain old Java classes they could work with in a strongly typed manner. And this was exactly what we saw yesterday. So with people, we had developers around, and they were looking at how information model is being used. All the time they talked about information model. They were in fact referring to this Java library and the classes. But behind all of them, they were generated, they were transformed from the ontology. So the ontology is the maintained single point of truth, and then there are derived programmatic representations, which are very valuable, especially for developers, because at the moment the semantic web community has come into an age of 10 years, maybe more, but the support, the tooling support is really weak. So we have Protégé, we have other editors, but we do not have comparable support like we have to integrate development environments with strongly typed languages. This is the rationale why we're doing all these model transformations. Having models is just one asset, but in order to enable developers and the community using it, you need some examples, of course, documentations of the code, and in order to somehow synchronize these three logical levels of model representation, we follow an approach of reference examples. So we have a Chinese scenario related to traffic observation. This is a synthetic scenario, and there is a number of reference examples defined in plain language and images within the conceptual representation. The same examples are formalized as instances of the ontology in a middle layer, in a middle column, and the same holds for the Java, for the programmatic representation of these examples. So wherever you come from, what type of stakeholder you are, you may look at those equivalent examples in the representation you like and you understand. Now we will deal with the information model in detail. And so where would it start? We started thinking of concerns of dimensions, which such an information model should cover. And it is often helpful to have a sort of figurative explanations. And I felt when looking at the concerns which are or should be covered by such a model, then the number of 6 just came into my mind, because there were mostly those identified on this slide, and following the example of the carbon molecules, we defined such a concerns hexagon. On the top level, you have the content, which is really the focus of the data set, where digital contents, data is being exchanged. But the value of data is generated only if it has sort of interesting context, like being generated temperature data or whatever data being generated in a particular area you are interested in, and being marked up with a concept which you are interested in, like knowing this data is about temperatures, is about, I don't know, is about particular factories you are interested in, and so on. Once you have content, the content needs to be somehow communicated. So this is the concern of communication in the lower left side. Once you are able to communicate such a content, you need to, in scenarios of businesses, of data markets, give it some expression of pricing, of usage constraints, which are which the commodity concern is dealing with, and where, of course, such a model would apply for any data market out there, which is quite generic. But the plus, the added value, which IDS, which information, which in this data space is providing, is the creation of a community of trust in terms of certification, in terms of providing reference implementations of trusted runtimes called connectors. So we will look in the following slides at the details of the individual concerns. So the concern content is defined as defining a taxonomy of digital contents, which have their particular interpretation and use. So the container and data, text, and software, we will not look at all of them in detail, but starting at, for example, a container, which is an aggregate composed of multiple individual defined parts. So this might be, for example, a zip archive. So you defined this as digital content of type container, and the content parts indicate the individual parts you would find, for example, you would find in it. The color codes used here will be resolved later on. Just a side note, the green one refers merely to the abstract contents. The blue one refers to the concretization of this content in terms of physical embodiment, physical shape, giving it, for example, a media type. And the yellow part is a particular instance, is a particular file, which shares, of course, the semantics of the green part of the content, which has been expressed in terms of the representation, but it is an individual and addressable, it has become an addressable artifact, the yellow part. So, and a further example could be in the text example. Text is considered any textual content which is intended for reading and interpretation by humans or other intelligent agents. And it is meant to stand for any representation of what is text, like document, being a screenshot of such a document or whatever. Okay, so if this content has a textual characteristics, it should be then followingly marked as a text. And once again, we have then the separation of the general content description of the representation properties marked blue and the particular instantiation marked yellow. And this is where I pass to Christian once again in order to compare what has been defined here in a snippet, in an excerpt in a turtle representation of the ontology, and now in a programmatic way in Java.
Yes. So, in fact, if you just to close the loop to what I said before, So in this slide, for example, you see an instantiation of the declarative model, which is basically here RDF, more concrete RDF turtle syntax. And this information, if you, for example, provide a connector with a self-description, you would formalize such an instantiation of the information model to communicate what your connector, what is data that you provide to the others. So because this is very specific syntax, triple-based syntax, that is not common to every developer out there. As I said, we have the Java library, and here on this slide you can see how the respective turtle instantiation of the model conforms to the Java instantiations. So actually you have the same, obviously the same three different parts of or perspectives of the information content, but what we express here as triples in RDF Turtle is expressed here in Java. So this is more easily comprehensible for developers. It is more easily creatable because you just create an in-memory object tree, which you can then serialize in RDF or whatever you want. So yeah, this is actually a one-to-one mapping from RDF to a very usable, for every developer understandable format.
Thank you very much, Christian. So I already introduced the different layers of the content description. Once again, summarizing, these were defined in order to separate out the different characteristics. So the content, the green one, is an abstract format independent template of describing contents. Like we've seen, what is in a text, or what is the container, or it is stating the type even of the digital content. The representation is a concrete format dependent template. It means it defines how it is structured, but it has no identity. It is not referenceable. And this both concept is exactly what is sufficient to describe an interface of a service, where you are interacting with resource, for example, and you do not have individual artifacts, individual parts, chunks of data you might know before, if they are not enumerated, like this is often done in standards like DCAT, which is done in terms of artifacts, which are materialized format-dependent instances of the content representation. What about resource? So the term or the concept of resource has been introduced here in order to provide a wrapper. So you see, resource is composed of contents. Yes, this holds for complex scenarios where you would like to identify a logical point, a logical node, where multiple different unrelated contents are part of. Either they are contained physically within an archive or not. It does not really matter. This resource is a starting point looking at somehow by the user related contents or defined as related. And the resource is an exact entry point to contents where further on the communication capabilities are added to, because the content should not be aware of how it is being communicated and retrieved. We consider this a responsibility of different type of node, which is the resource. Where does this model come from is explained later on. This is one of the possible reduplications or possible variants how such model could be instantiated. Where this does come from, this is rooted in evaluation of publication patterns we observed in the European data portal, where the rigid structures defined by former or by other standards we rely on, like DCAT, were not followed in a sense as intended by the creators of the standard, by the users of the standard were more creative. They had different requirements, and they sort of used the DCAT standard in a more non-standard way, an unexpected way. So let us look behind and explain a bit the rationale behind our model design. So this is the plain DCAT 10 core model, where a catalog is listing abstract contents represented by the data set concept, and these are concretized in terms of distribution. So what we felt, the distribution intermingled the concept, the DCAT concept of distribution intermingled the concept or the responsibility of stating how content is represented in terms of media type, sort of representation standard or profile, how they are now called in the DCAT working group, where we are members of, and we very closely follow the developments. And on the other side, the same concept was stating what an instance, a particular embodiment of this representation is. And so we decided to split up those dimensions into the representation and to the abstract instance concept, which might be either an inline value. For example, if you have any type of digital inline value as part of your metadata, or which may just relate or refer to an artifact being a file, which has, of course, an identity, a byte size, name, checksum, whatever. And all these characteristics are not present in a representation, which is just a generic expression of how such content is shaped, how it is physically organized. So this is the rationale and insight we had when looking at the distribution concept of DCAT. And looking at a data set, we often saw the need of splitting up the singular concept of this data set into maybe a recursive structure of digital contents. And the further need we saw is there should be a next or further node referring to such a digital content, because this was a bit overloaded. The dataset concept was a bit overloaded, and therefore optionally the resource might link to further digital contents which are related to it, or defined or be a digital content. So this is the explanation why we use composition and subclassing at the same place. This is all now at the moment talking about the content, digital contents, how this is expressed. Let's look at the different the other concerns shortly. How context is being, what is context? So context, as understand it, is the reference of content in question to time, like the coverage, which, if we have statistical data, which temporal coverage, which interval in time has been covered by the data. Then which space in terms of geometric model or named entities, for example, countries, is covered by the data. In terms of world context, for example, what is the subject of the data? In our scenario, it might be a highway E31, where some statistics has been collected about. And especially this context would be one of the entry points users of a catalog would look for. The data becomes important and relevant because it refers to the correct today, to the context they are interested in. So the concepts, why are we looking separately at this concern? So the concepts might be looking at the bottom, defined quite easily or simply in terms of keywords, like stating this is a report, highway, statistic, whatever. This is just simple words, somehow managed maybe by the environment, but further lifting this up into becoming course concept. So this is a sort of terminology which might be formally shared and be used across companies, across communities, and which is further organized in sort of concept schemes. So, and these are then vocabularies which are state a sort of contract, semantical contract when talking about data. So, in a sense, we, for example, define the concept of a year or the highway in order to be enabled, give the data a sort of semantics. For example, if a parameter of a function, for example, is looking at a name, at a string or whatever, and it is given a sort of interpretation being to be understood as, for example, name of a highway. So concepts are a further crucial aspect of making the data better understandable and exploitable for users. The next concern, a very important one, once all these other concerns have been defined, is the communication, how the data is mediated. Let's look at the key concepts. So the endpoint, in our understanding, is specifying a path, a hierarchical name within namespace of a host. Endpoint is a sort of identifier within a host, which is a network entity that implements any communication protocol and supports interaction that endpoint's path is. So we do not follow or we do not force users on this data space to stick with only one predefined protocol. And this is our approach of handling this variety. We just state, okay, looking at those different protocols like HTTP, MQTT, MQP, and whatever, they do have the notion of paths, of topics, whatever. They will be defined in the endpoint. So these are defined, or they live in namespace of a host. So this is the host about. They often communicate in terms of messages, which are given a type in our ontology in order to make the individual interactions clear and transparent. What does it mean when sending around a message, a type of message? So message is a type of specified metadata describing the payload exchanged by interacting connectors by means of the hosts. And interfaces conceptualize the operations and interactions taking part in dynamic scenarios where they are needed. Let's look at interaction types we consider. So you either are using legacy APIs and protocols like RESTful APIs, which have already been defined in your environments. So you would go on and define a static endpoint, for example, just allowing to download download of artifacts with no pain. Or you would define an interactive endpoint which needs a definition of interface and further mappings, and you are fine using simple protocols. But this solution is restricted because no further metadata, for example, would be involved, which is present in a message-oriented IDS way of communicating. What is it? I will look at it later on. But just the message here is there's the interactions taking part through the protocols and following standards, and there's an extended, like REST, an extended on top of it, an extended communication model, which is message oriented, which is the preferred way of communicating in IDS. And they are defined, for example, message endpoints where particular type of messages is reserved. Let's look at how is modeled the exposure of a static artifact. We have a file, we have an artifact, and there's a static endpoint pointing to this artifact description. Endpoint artifact is the description of this artifact, of this file, which is given a particular path within the namespace of the HTTP host defined below. So any client willing to download this artifact and download this file would first resolve the host, concatenate the path to the access URL, and go on. There's no interaction involved, which is the case in the current example. In order to retrieve whatever data in an interactive way, you would define an interface in an interactive endpoint where there is, for example, a parameterized path. You would need to fill with parameters by terms of the operation binding. Operations are identified items of interactions. In order to learn on how to operate them, how to invoke them in using a particular protocol which is supported, you would look then at the operation binding, which is not detailed out here. At the moment, operation binding is simply a Swagger file for HTTP and REST, for example. And if there are any similar standardized protocols for defining or API languages for defining such interfaces, which we are missing, for example, for other protocols, then they would be, of course, usable in order to define an operation binding. Okay, so interactive retrieval of data will require a definition of an interface and binding of the operations of the interface. Then let's look what an interface is. So here is an example of resource interface. So we have resource, which defines one interface and one operation, which is a query operation. So it expects some parameters coming in, and there will be the data, whatever content has been defined in the resource will be retrieved back based on the inputs provided by the client. So the UML model on the left says interface has an aggregation of operations, and then the operations may have parameters or have parameters which refer to a content model. And exactly this content model was introduced previously. So it is reused, even the content model is reused in static and in dynamic interactive scenarios. This is the takeaway message of this email, of this slide. Fine. So we were looking at a plain, at a legacy type of interactions. Now looking at the IDS-oriented one, then we need to define messages for every interaction step. And this is exactly what makes the communication of the interaction processes even easier, because at every point of an interaction, we may refer to a type of message which takes care of this request or response or notification. And see here, please, for an example of an excerpt of the message taxonomy. For example, we define request messages like the artifact request message to request an artifact which is identified by URI, and then expect as a client an artifact response message come back with a particular metadata in the header of the message and the artifact in the payload of the message. The messages are likewise important means of infrastructure interactions. This is an example of interaction for contract negotiating a usage contract. If you as a client are interested in particular data, in particular resource, you would first ask for a selection of usage constraints or usage conditions which are appropriate for you as client, and then such a contract negotiation process would start and end hopefully with signing a contract, a digital contract, and retrieving the data. I will not dive into details of the contracts because they will be the important part of the policy language and contract webinar on 21st of December. Just let's look at what we mean at specifying of contracts and usage control conditions. This is done on a declarative way. So all the definitions in the ontology are so-called specification level policies, which are declarative, the contracts in language readable and interpretable format, but with themselves are still abstract and need to be turned into more implementation level policies, which is the responsibility of our colleagues from Fraunhofer IDSA, for example, or Fraunhofer ISAC, who develop the contract, the usage control enforcement frameworks, where all the magic then happens. So then the further community aspect would be the pricing. There's some pricing models, but I do not have examples in a moment. So looking at the last concern left, community of trust. This is defined, for example, by participant models, where the important part of the trust is a certification process. When applying for membership in the industrial data space, you would normally undergo such a certification process, and the resultant certification level is, for example, expressed in terms of the ontology. Then further aspect of community of trust is trusted infrastructure, trusted software, and the connector is one of those because this is the node, the entry node to the industrial data space. How it looks like could be described here: a broker, which is a metadata repository of data sets, mediating and responding to queries about available data sets around, is of course itself a connector. So it defines a host, it defines a sort of security profile. So the clients connecting to it may know about its, app isolation level, about its security features, which are laid down in the security profile. And of course, they are interested in the catalog of the broker. The catalog just lists the resources available at this particular host, at its particular connector. And of course, we have the definition of a host, which is a networked entity, as I was referring to, providing all the communication, or implementing all the communication. So, and certification process was already mentioned as an important aspect of the community of trust. Let's just simply shortly look at how the information model is used. This is a connector registration message. Connector comes up in the data space. It has somehow identified by multicast protocols, identified a broker, and it sends out a message, indeed identify the connector and all the resources it offers, the security profile. So this is how the information model is used in order to describe a new node on the block, which is making available and publishing its resources at the registry, at the broker component. And the highlighted parts are the parts of the multi-part message, where the header is the more interesting one. It is the general metadata accompanying any such message. So connector available message is, for example, the type of message in question here. And the payload in this message, it happens as well to be a metadata, because this is the self-description, so-called self-description of the connector being sent around, but it might be any other type of digital content in a payload part of the message. So what is the ontology governance process? To close up, where do we manage all the sources of the ontology, of the declarative representation? These are on GitHub. So you would find the code lists, for example. I refer to like types of media types supported, or whatever, which were translated from Jana. Then reference examples I've mentioned, some utility annotations for validation purposes, for example, and of course a variety of models which cover the aspects, the concerns we talked about, and there are as well some views defined, for example, in order to generate a glossary of terms out of the ontology. So we have defined some types of issues in order to enable the community to come in, to interact with the group and provide feedback. What is the group? Who is taking care of the governance, of the maintenance of the process? This is the working group, sub-working group for information model, part of the working group architecture and Industrial Database Association. The research partners are Fraunhofer FIT, IDS, ESST, and some other institutes. These are the leading institutes, and of course our partners from the industry. Sensor Schäffler, Andreas Müller, for example, is present in his call, and he's very active participant. Sebastian Trump, for example, supporting us from a sensor, supporting us with a continuous integration and build processes. Boehringer Ingelheim, Signal Cruncher are examples of companies present in a group. And so this is the process, how the issues are being handled by our sub-working group. I would ask you to have a look at it when the slides are published and maybe to pose questions. Just to sum up, because the time is short, we were looking at most of these concerns, which are now detailed out here at this slide. We were looking at the content, at different layers of meaning, shaping the representation and the instance, the artifacts of content. So then we were looking at the context. What does it mean? How we consider the different types of context and contextual information, the concepts which make sense, which give meaning to content. We were looking at types of how content is being communicated in a distributed data space, how this communication is modeled, and then what are the aspects of making content a commodity, and what are the definitive features needed in order to provide a community of trust, which is the very purpose of the industrial data space. So I seem I'm done. Thank you for your patience, and then keen on listening to your questions. Thank you.
Thank you, Jaroslav and Christian, for this very interesting presentation about the information model. Are there yet any questions from the audience? Let me have a look to the chat function. Not yet. Maybe let me ask a question. You talked a lot about ontologies and gave a short introduction to some tools that can be used to develop ontologies. For example, you stated Protégé, which is a very common tool for that. In your opinion, Jaro, what are the best tools to do holistic ontology development?
Mm-hmm. Thank you, Christoph. I think I do not know these tools because they are mostly commercial, and we're not really going to pay €1,000 for top quadrant IDE for developments. So I really do not maybe know the cool industrial and commercial tools. By Protégé, for example, is quite fine. And there is some example. Just let me look at it quite a beginning where there were screenshots of our IDE. So at the moment we use, so this is Eclipse, for example, and at the moment we use IntelliJ, for example, with some additional plugins and sharing the code on GitHub. So this might be not appropriate. We have developed for some purposes our tools, our scripts, and there's continuous integration process being developed. But at the moment, I do not really see a comprehensive solution on the market. I think there are many fragmented solutions, like, for example, APIs, all APIs. The Jena framework, for example, is providing very valuable command line utilities. So it really depends. We have examples of some scripts and libraries in the GitHub repository which we are using, for example, for validation purposes. I don't know whether you have an opinion on it.
Well, I think with most of the tools, I think there are not really best tools available. As Jaro said, it depends on your experience with RDF, with creating vocabularies. We can just talk from our experience. And for example, if we're developing, as Jaro said, this model, we're very fine with creating the ontology in a text editor, expressing some tests, running these tests, and then iterate over it, all on the text-based tools. But of course, I mean, you're always free to load the ontology into Protégé and use their tooling, their visualization. Everything is possible, and I think this is also the advantage of using open standards here. You can just take the ontology, use any tool you think works best for your experience, for your purposes, and then just go and start contributing.
Thank you. Are there further questions?
Thank you.
Thanks.
Are there further questions from the audience, maybe? I would be interested about one more thing. How could I get involved with the information model? Where is it available? And let's say I have some software developed. How could I make use of the information model now?
Yes,
for instance,
very good.
Talking about binaries. Yeah.
Yes, very good. So this is a question about maybe how to, what use could be done of the representations, for example. So you would, given the conceptual, you would just read it. Given the ontology, you may extend it. You may understand and extend for your particular purposes. This would be found on GitHub. Okay, Christoph? And using the tools of your choice we talked about, then would you go on, and so this is the ontology, and using the and looking at the Java representation, the programmatic representation, there is a link to the library in the repository maintained by Fraunhofer ESST. So you would then, for example, use this as a dependency in your Maven-based development project, okay, and create whatever instances of the model you need, for example, in order to enroll a connector in the network. So if your position is not just being a developer, but become a contributor, if you're interested in contributing, then the governance process would be interesting. So you have looked at the source code, and you would have spotted one of the many bugs which are still in there. So you would, for example, issue a bug, or, for example, issue a question on GitHub, or ask for enhancement, an extension. Okay? So this, the further, if you are interested in the ontology, then please use GitHub for communicating all the issues you have found and extensions request you have with us. And the process, the working group, the team would then go on and analyze these proposals, create solutions which the Fraunhofer is responsible for, and provide and deliver intermediary develop versions, and twice a year, aligned with the meetings of the architecture group, there would be stable master branch releases published. So if you are interested in extending the model and collaborating here, then this is the way to go.
Okay, thank you very much. I think we're just in time with the session. If there are questions after the webinar, don't hesitate to simply write us an email. We will come back to you with answers on your questions. So thank you for your participation. Thank you, Jaro. Thank you, Christian. And have a great day. Goodbye.
Thank you very much for coming. Bye-bye.
Thank you. Bye.